What's up, guys? And today I'm going to do quadratic transformations, the simplified version. I'm going to simplify Professor Devin's version. So we have our parent function, which is f of x is equal to x squared. And first we're going to do translations. Now, if we want to translate our function 2 to the right, we would take our parent function, and inside the parentheses with the x, we'll subtract minus 2 in order to translate it to the right 2 units. Now, this is how the graph will look. So our parent function here, we're just going to move it 2 to the right. Boom. So whenever you want to translate to the right, you'll subtract x by 2. Now, what do we want to do if we want to translate it to the left? Now we'll do the opposite of subtracting 2. We'll add 2 to f of x. So f of x plus 2 just means that the parent function x squared will move 2 to the right. Right here. 2 to the right. Now let's move on to our vertical translations, which are going up and down. Now instead of doing anything inside the parentheses to x, we'll do stuff outside of it. So if we wanna translate it up vertically 1 unit, we'll just do f of x plus 1. Now our graph will look like this. It just goes 1 unit up. It's not really on the y is equal to x is equal to 0, I mean. Now this isn't really drawn to scale, so alright. Now you get the gist of it. Now f of x, if we want to translate it down 1 unit, what do you think? Well, of course, we'll subtract it by 1. Alright, now it's being moved down or translated down 1 unit. Now onto our second part. We're moving on from translations. We'll do reflections now. So likewise, we have our parent function f of x is equal to x squared. Let's draw the graph real quick. Alright, so if we want to reflect our function over the x-axis, what we'll first do is that we'll take a -1 and we'll multiply it to our f, or to the entire function. This will make it so that our y values change, flipping it over like this. Holy crap. Like this. Now on to our second part, which if we want to reflect our function over the y-axis. Now instead of multiplying it on the outside, multiplying -1 on the outside, we'll do it to the inside of the parentheses. Now this will only affect our y values, but as you can see, if we reflect this over the y-axis, nothing changes. So we'll just be left with this function. Finally, we have our vertical stretches, vertical shrinks, horizontal shrinks, and horizontal stretches. Now, if you want to perform a vertical stretch, you'll simply multiply our f by a value that is greater than 1. A value that is greater than 1 is 2. 2 f of x is equal to, that's just it. Right, now when we perform this vertical stretch, the function itself will become narrower, as you can see, compared to our parent function. Let me just draw the parent function. The wider one will be the parent function. So this is a v, is a vertical stretch. Now let's move on. Now, what if we multiply our f by a number that is less than 1? A number that is less than 1 could be 0.2. 0.2 f of x. First of all, let's draw our parent function. This will be our parent function. Now, when we do a vertical shrink, this is called a vertical shrink when we multiply a number that is less than 1 to our left. Now, you will notice that when we do this vertical shrink, the function actually becomes wider. Next, we have our horizontal shrinks. Our horizontal shrinks can be performed by multiplying our x value by a number that is greater than 1. A number that is greater than 1 will be 2, of course. F of 2x. Now, like our vertical stretches, our function will also become much more narrow. Now, this is our parent function. Now, if you want to find a vertical stretch, you just gotta divide our current x values on our parent function by 2. Now, do you see how narrow it gets? Alright, let's move on to our final one, which if we multiply our x value by a number that is less than 1, number that is less than 1 will be, of course, 0.2. f of x 0.2x. Draw our parent function again. Now, opposite to how we find our horizontal shrinks, finding our horizontal stretch will multiply our x values on our parent function by a value of 2, by a scale factor of 2 actually. And as you can see, our function becomes wider. Now, to close off our video, we'll go over the tips and tricks for our vertical stretches, vertical shrinks, horizontal shrink, and horizontal stretch, and how we can identify them. As for vertical stretch, a number greater than 1 is multiplied by f. So, number greater than 1 is 2. Now, if we see that a function, compared to its parent function, is being multiplied, its y values being multiplied by 2 times, right? Then it's a vertical stretch. If it is a vertical shrink, a number less than 1 is multiplied by f. If our y values are being multiplied by a number less than 1, that is a vertical shrink. If you can see it on the graph, it gets wider. Vertical stretch would just mean that the function is getting a bit narrower. Now, for our horizontal shrinks, number greater than 1 multiplied by x would mean that our x values are being divided by that number. Our x values are being divided by 2. Now, it's quite the opposite for our horizontal stretches. Number less than 1 is multiplied by x. Now, when that happens, let's say 0.2, our x values in our function will be divided by 2. A horizontal shrink, like its name suggests, also makes the function much more narrow. Now, compared to our horizontal stretch, it's the opposite, it becomes wider.